let's move on to class. So last class we had discussed about how to mostly how to set up mini cube and how to set up mini cube and all, and how to create a sample pod, and also just we saw, right, how to check the pods, how to check the nodes and all. Anyone tried the setup and all? Any issues, any challenges? So mini cube or Docker desktop. So Docker desktop also same, and so we need to follow some steps. Let me come to here. Can you see my screen?
Yes.
Docker, Docker desktop, Docker desktop also we can same steps only. So first we need to install the kubectl. So first you need to install the kubectl. First you need to install the kubectl, and once that is done, same. Even if you Google it, we are getting same only. And install AWS CLI. This is right, AWS CLI. I hope everyone know what is AWS CLI and work with. And first you need to install the download the first step we missed, right. So first download Docker desktop software. Already last class I shown, right. So download the Docker desktop software, and we need to install the CLI and kubectl. That's it. So once we open, so we'll get like this. We can use anyone. Both are same only. It is working in our local only. In our local only. So we'll see like this. We need to install. First download the, like this we'll get one. If you go to download, see here Docker desktop installer. We'll get one exe file. So we'll get one exe file. If we click on this, it will take time, and also it will occupy nearly 10 to 15 GB space in our local hard disk also. And so next we need to install the Docker kubectl. Okay, kubectl command line tool. We need to install the command line tool. Why you need to install? So we need to install the everything we are running via command prompt only, right. So that is next we need to install AWS CLI. So this is the AWS CLI. Okay, I will show you. If anyone want to, I will show you. Already in my mission it is running. In my mission already it is running. Just try it. And mini cube. Last class we discussed, right? Mini cube. So how to install mini cube and all. Only three steps. Three steps, right? Same way. Now once if you open, we can use mini cube or Docker desktop. Both are same only. Now if you go to here settings, once you get this option, and so this is the Kubernetes. If it is not running, here also we can see Kubernetes is running, and so Docker engine also running. By default, if you open this one, automatically it will running. Suppose in case if it is not running, and so that case go to settings and click here and start. That's it. No need to do anything. No need to do anything. And so next directly, so now directly we can work with so Kubernetes. Now let me go to here anyone. Let me go to here anyone, and I am going to create one folder. That is your wish. Anyway, once setup is done, go to anywhere. Go to anywhere. Just I am going to here my C drive. Where is my C drive? Anywhere. That is your wish. And so create C drive. Just I am creating one folder. Just I am going to this path. Go to this path. Just type cmd, automatically it will go to command prompt. Okay, so command prompt. So if you want to check how many nodes, how many parts, so here what is this kubectl? Every time I am typing kubectl, right. So every time I am typing kubectl, kubectl. Suppose if you want to see the get nodes, so see here get nodes. So right now I have only This is the Docker desktop, right? So here see control pane. Only master is available. Master is available. Master is available. And if you want to see the parts, if we want to see the parts, same command kubectl command line tool, and so get parts. So right now I don't have anything. See, I don't have any pod, and so I don't have. I have only one node, and kubectl get ns. What is ns means? Namespaces. What is ns means? Namespaces. See here, right now, so these all are the default namespace. These all are the default namespace. If we create any pod, if we create any pod, by default, that pod will deployed here only, default. So there is a kube node release also is there, kube public also is there, kube system also is there. So these are the namespaces. So last class we discussed, right, what is namespace, and so how it will work. What is namespace and how it will work means, namespace is nothing but, here we discuss, right? See here, this is what is namespace. Namespace is the virtual cluster inside your Kubernetes cluster, and these are the default. So default is for deployments. If you are not mentioning anything, if you create any pod, if you create any object, Kubernetes object, if you are not mentioning anything, by default all pods will come to under the default namespace only. See, which is a quickly way to create mess that way harder to clean up. If you want to, we can do. And this is a kube system. So we are not going to do anything. This mostly see it is for all things related to Kubernetes system. It is used by Kubernetes system only. No need to do anything. There is a kube public also is there. It is readable by everyone, but so the namespaces is reserved for the system usage only. So this and all mostly we won't touch anything. We won't touch anything, and so if you are not mentioning anything, by default all parts under created default namespace only. Suppose if you want to create any namespace, so last class we seen, right? So kubectl create namespace, namespace, and namespace name, whatever you want. For example, test is my namespace name. Now namespace is created. How to check it all namespaces? This is the kubectl get kubectl get ns. Now see here, test namespace was created. In real time, there is many projects, right? So not only single project. Here mostly some cases I am not using, some cases I am not using any namespace. But if we come to real time, so most of the cases we are using namespace only. Under the particular namespace, so this is your Kubernetes cluster. This is your Kubernetes cluster. Cluster is nothing but group of servers. Okay. Now I am going to create one namespace. We are going to divide multiple namespace. So for each project, we are going to create one namespaces. If you want to deploy your application, just assume. So this is the, so if you assume, so this is the one project. For example, CRM project. Okay. CRM related, I am going to deploy here only. For example, this is the healthcare. Okay, so all related healthcare projects I am going to deploy here. For example, this is the what is this, this is banking. Okay, so I am going to deploy banking related so projects and all here. So here no confusion. Why you need to create namespaces? Suppose if you don't have namespace, and by default all are deploying which namespace, guys? Default namespace only. If you are not mentioning anything, all namespaces are deploying default namespace only. Now, so for example, healthcare related projects, I am going to deploy only particular this namespace only. This is one NS namespace. We created one NS. This is also one namespace. We are splitting multiple namespaces, same area. So why main purpose is security. There is no confusion. Correct? So if you don't have any namespaces, and everything we are going to deploy the default namespace. Even if you deploy default namespaces, maybe some cases we are going to delete, we are going to modify some other projects, other deployment activities. So knowingly, unknowingly, we did something, right? We are going to do something. So to avoid that confusion and also security purpose, mostly in real time, we are going to create multiple namespaces, and under this namespace healthcare related I am going to deploy here only. There is no confusion deployment. And so this is banking related all deployments and all I am going to deploy here only. So, and if in a CRM I am going to deploy this particular namespaces. Now see here, so some security, right? We are not disturbing these healthcare projects. Even if you new to this, here there is multiple namespaces there where we want to deploy. First we are going to deploy. We are going to decide. So we are part of which namespace. Whether this is healthcare. I mean, in real time we can see many namespaces. Okay, and based on this we are going to deploy that particular namespace. Now already last class we discussed. Now, so if you want to see, if you want to create any any pod, if you want to create any pod, so last class we see, if you want to create any, I want to create one pod. So cls, so what is the command? Kubectl, 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 create kubectl run, and a name, nginx. Yesterday I created, right? Run nginx and hyphen hyphen. This is the imperative mode. Anyway, multiple ways we can create. Image equal to nginx. So anyone, any doubt what is this nginx? This is the one image, right? So where we can find these all images? Docker desktop. Already it is available. So directly I am using. In Docker we are using one command, right? So Docker run. Okay. So if you use so Docker search nginx, right? So there is many images coming. So how these all are images coming? So there is some default images available. So that is the reason we are directly I'm using that images. If you want to create containers, Docker, how to create container, how to check contain, that is no, right? How to check that all containers. So Docker, so everything working same Docker, all commands working here. So in every worker node there is a components, right? Pods are running, Docker also is there, and kube proxy and kubelet. So that is the agent, one network rules, and so Docker and pod. So right now I don't have any pod. Simply I want to create one pod. Simply I want to create one pod. So what is the command? So kubectl, kubectl, kubectl run, and name we can give any name. So dev nginx I given some name, anything that is your wish, or else test nginx, and hyphen hyphen image, which image you want to take. So for example here I am using nginx. Okay, and if you want to we can set port numbers and all, we'll see here. Pod is created. First we can see pod, this is the pod, and this is your name, pod name, and created. How to check all pods? See here, kubectl get pods. If you use this command, now see here, this is the pod name, and so ready one by one. Status is running, and restart not at 15 seconds ago created. So now see, kubectl, kubectl get pods, get pod hyphen o, and so wide. I want to see few more columns. Now see here, now see here, this is your, and so get running, status running, age, and this is the IP. See here 10.1.2.86, and this is my cluster name, and so here nothing, no, none is there. So now we can see some information. Now same way, if you want to see some service also, now see here, sorry, CLS, kubectl, kubectl get svc. If you want to see service object, so this is the default service, this is the default service, this is the cluster IP, and no need to change anything. If you want to we can create our own, if you want to we can create so our own, if you want to we can create our own, what is this service object also we can create. Apart from this I don't have anything. Suppose if you want to see all object, okay, kubectl get all, get all. If you see here, so now I have one pod is running, and so only default service. Apart from this I don't have anything. Now I am going to create, so I am going to create my own image. Already I have, I will show how what is the output and how it will work. Same, I am going to create one more pod. See here, kubectl, just will see output how it will work. Compare it to Docker, kubectl, and create, I am going to create a deployment object. we'll see later, we'll discuss later, just understanding purpose. Deployment, and so we can give any name. Okay, test deployment dep, I given some name. And so hyphen image, hyphen image equal to which image you want. Already I have one image, right? So regularly I am using one image, right? So this is my register name slash, so what is that, maven, hyphen web hyphen application colon tag. So I am using, so my tag is 1. This is the next, hyphen port. This is the web application, right? Hyphen control minus hyphen port, port, port equal to, so what is this, 8080. Okay, and so next, hyphen replicas, I am using some replicas too. I am using count also too. I am using some count replicas, how many replicas I need. Just I am using my image. Don't leave it all these things. Just remember, this is my image. This is the web application. This is the default port number. I am using Tomcat related. Here I am using Tomcat image. And how many replicas? This is the pod. How many pods you want to create? Now see here, deployment object is created. What is that name? This one. Now check it, kubectl. Already I have one pod. Now I created replicas 2. 1 plus 2, total 3. Get pods. Now check it here. Now how many pods? So this is my, just now I created. This is the, just now this is the Nginx related pod, and these are related to my pod. Now see here, 2 pods are running. And so age also we can see. Now if you see kubectl get svc. So if you want to access, we need one service. So anyway, we'll discuss later. Just I am showing. I want to show output, right? So now 2 parts are running. So if you want to access browser, this is the web application, correct? If you want to access browser outside the cluster, we need to create one service object also. So as of now, you don't know what is service object. Just I am going to create one service object. Kubectl expose. These all are the so imperative commands. Command line I am executing, but mostly we are going to use so manifest file. Coming days. Mm. Deployment, and what is my deployment name? What is my deployment name I given? This is the test dep name. This is the test dep. Test underscore d hyphen dep hyphen, so hyphen dep. And so here here I am using some type. Actually there is multiple types available, service types. Here I am using load balancer. This is very important. I will discuss later. Load B and C here, load balancer. And so what is the port? Hyphen port, port equal to, I am using same port number, service port number also I am using same 800. So now service also created. Now service objects also created. Now check it, kubectl get pods. Same 3 pods are running. If you want to see the service, kubectl get svc service object. There is 4 types of service object available: cluster IP and node port, load balancer, and so that external name and all. Now I am using load balancer. Load balancer means so I want to access my application outside the right, browser. This is the web application, right? So cluster IP means inside the cluster only we can access. There is one more type also is there, node port. So that is also we can use. Now this is I am using load balancer. Okay, we can use anyone. Now this is the, see here, external IP host, local host. Local host means right now my Docker desktop is running my machine only. So now this is the local host. Now see here port number 8080. Default port number I am using 8080. Now how it will work? Now this is also service also created. Anyway, I will discuss later. Just I want to show output. That's the reason I created one service object. Now how to access, how to see whether it is running or not, my application is working or not, I want to check. Go to browser. Just what is the external IP? Here I given what is coming. External IP. Localhost, right? Come to localhost and localhost colon 8080 and so if you use means now see here. Now Tomcat server is running. So now Tomcat server is running. My application also deployed. My application also deployed. Now I'm going to access my application. I have a context path, right? I have a context path. So what is this? Maven web application. This is my context path. So this is my application context path. If you use, so now see, this is the sample application. In that image I deployed, this is my sample application. So now I can access my, in real time also we are using same process. Nothing, it won't change anything. But instead of your context, there we are giving my project name. That's it. And in that image already everything we configure and so just I'm giving so my context part my image name only, but right now I am using CLI, right? So mostly we are using a manifest, some Helm and all we are using. Just for understanding purpose I created simple, I created one deployment object and so this is my name, this is my image name. This image coming from where? Already this image is available docker hub.docker.com. So this image already available. This is the tag name, this is the image name, and this is my register name. Okay, so this is my register name. This is my register name. This is the default port number. My application port number I set 8080. That's it. Now see here. So how the application is running. So like this we are going to create multiple parts. Now one more thing. So what is the advantage of so Kubernetes? Already Docker, you know, right? So even one pod is deleted. One container is deleted. Now see here, container is deleted. Who will create container? Docker? Automatically it will create, or we are going to create? For example, my Maven web application, this container is I created in Docker. Okay. Okay. So now this is running. Suppose in case this container is deleted, again who will create my Docker? We only, right? So again we are going to create. But in Kubernetes, so there is a one concept is a replication controller and replica set. So it is handling pod life cycle. Even pod is, this is the pod, right? So this is a container. Inside this pod, one container is running. Now observe here one by one. One container is running. So here this is one more pod. Here also one container is running. Suppose I am going to delete this pod, this spell pod. So see here I am creating manually and automatically it will create. You can check it. kubectl, kubectl, delete pod, and I am giving pod name. I am giving pod name. Now see here, observe here. This is the RBZ. This is the 6RS. Just remember last three letters. I deleted pod. Pod means inside pod container is running, and I deleted. Now who will handle these pods and all, these containers and all? Now check it. How many pods still running? kubectl get pods. Now see here, automatically one more pod is created. See here, I deleted RBZ. I deleted RBZ pod. Okay, inside this pod container is running. So immediately it is creating one more pod. So can you see this pod name here? No, right? So this is available, 6RS available. Automatically within the seconds it will create one more container, one more pod. So inside this pod, see, your application is running. There is no application downtime. So simply if you want to understand why you go for Kubernetes, without application downtime, we can deploy your application multiple times in single day, any times. So no need to take care about these things. Everything taken care by Kubernetes. Even pod is deleted. Okay. So automatically it will create new pod. And also we can easily scale up and scale down. We can easily scale up and scale down. So right now see here how many pods are running here. Two pods. I given replicas equal to 2, right? Somewhere I given. Check here. I given somewhere replicas equal to 2. Replicas equal to 2. Suppose if you want to, we can scale up, or if you want to, we can scale down. How many parts you want? So that is there is many features available, right? Now we'll see that features. Now we got some idea. Now we'll see that way. So what is main features? Now see here, what are the features of so automated scheduling. So Kubernetes provides the advanced scheduling to launch the container on the cluster nodes based on the resources. So for example, I created. Now come to here. So this is already right. This is a master. Now you created so worker nodes. I have two worker nodes. I created one pod. So this pod, which worker node you want to deploy? So this is one feature. So this is the master. This is the master. Right? What is the purpose of master and what are the main components and all. So this is the master. Okay. Now master. So there is four components, right? API server, correct? And etcd. Next scheduler. Next controller. Control manager. Okay. Now I created one pod. So here I have two worker nodes. Which worker node you want to deploy? Who will decide? There is one feature is there. See, this is the node 1 and this is the node 2. So which worker node you want to deploy? So this and all we can set it. That is the one feature. See here. So automated scheduling. Kubernetes provide the advanced scheduling to launch a container to cluster node based on the resource requirements and right. So other constraints. So while not so sacrificing the availability. So you can schedule. So already what is API server, etcd, what is scheduler. Scheduler keep on watching the parts and these parts are assigned to particular worker node. Which worker node you want to deploy? So that and all taking care by master only. Now self-healing capabilities. See, Kubernetes allows to replaces and rescheduling containers when nodes die. So suppose unfortunately my node is die, my node is not working. So here remaining story same only. Here we can see pods we can see and Docker also available and so kubelet and kube proxy, correct? So here also same components available by default. Pods, next Docker, kubelet and kube proxy. Okay. Now one is scheduling concept, So which worker node you want to deploy? Coming classes we will learn. Just I am showing only advantages. Okay. Practical we will see coming classes. Now see here what is the second self-healing capabilities. In case unfortunately this node is not running, there is some issue on this node. So some issue on this node. Okay, so this node is not running, this node die goes down. See here, so self-healing capabilities. So see rescheduling, replacing and restarting the containers which is died. So already see here Kubernetes allow to replace the rescheduling containers when so node die. It also kills a container that doesn't respond to user defined health checkup and so does not advertise them to client until they are ready to serve. So for example, here one pod is running, here also one pod is running. So here one pod is running. Just assume here one pod is running and so this is the running. One pod is running. Okay. So here also one pod is running. My application running in two machines. So unfortunately, now I deleted one pod, right? I deleted that pod wantedly. I deleted that pod. So if pod is deleted, what is happening? Automatically it is recreated, right? Yes or no? Automatically it is recreated because of replication. In case this node also not working, there is some problem on this node. Now, so the request, so it won't go this one, right? Now in this case, so automatically it will recreating and automatically it will retake recreating. Even if you send any request, this pod is not receiving request and it will disconnect this pod and it will go to request only this pod. This and all taking care by Kubernetes. You don't worry. There is many features available. So that is. Now see here, automated rollout and rollback. Suppose in case I deployed one new version. So current version is, right here it is running 1 point. So here I deployed image name Maven. So web hyphen application. I deployed application version number 1 I deployed. So next week or next month I am going to deploy new version. This is the new old version. Everything working fine. There is no issues. So now next release means every week or every 2 months based on your requirement, based on client requirement, we are going to deploy it. For example, next release, I am going to deploy new version. There is some new enhancement. Developers they added some new versions and all. Now see here. Now I am going to deploy new version. Maven web application. I am going to release new version. Now I deploy new version, but unfortunately this new version is not working properly. So unfortunately this new version is not working properly. Now what you need to do? Immediately you need to move to older version, right? Otherwise the application down. Otherwise the application down. So we deploy new version. You deploy new version. So unfortunately there is some issues on the new version. Now automatically you want to roll back to previous version. That feature is also available. See here, automated rollouts and rollback. Kubernetes rolls out changes and application its configuration while monitoring application health to ensure that does not kill all the your instances at the same time. So if you want to we can simply roll back to previous version. Roll back to previous version. That feature is also available here automatically. You don't worry. Even this new version is not available, that is not working properly, immediately we can roll back to previous version. Now see here, and horizontal scaling and load balancer. You know what is load balancer? Distributing your incoming request to multiple instances, right? So that is the load balancer. And also auto next horizontal scaling. Right, a Kubernetes scale up and scale down application as per the requirement with simple command using UI or automatically based on CPU usage and all. Right, AWS there is one concept, load balancer and auto scaling. Right. So load balance means, right, ALB, load balancer, and auto scaling. What is auto scaling? So now I deployed one application. I hope everyone know ALB. Okay, auto scaling. Correct. So what is auto scaling? For example, I deployed one application. Just take Flipkart or Amazon, any one website. Okay, just assume. So normal days, this is one mission. They deployed one application. So they deployed one application. What is happening in real time? For example, just assume. So this is the our CRM project or Flipkart, anything. Why is everything it is changed to okay Amazon? Okay, anything that is your wish. Amazon.com, anything. This is my application. Now I deployed one application here. I deployed application. So now application is running. Now application running. This is a one server, and so this server can handle at a time how many requests. So it will handle. So for example, just assume 10,000 requests at a time. It is this server is can handle 10,000 requests. Okay, so 10,000 requests. So 10,000 people can access at a time this server, this application. So just assume in festival time, some offer time, so multiple people visiting this website, right? So that time what there is, so multiple requests coming, and nearly so we are getting so that incoming that request and all 15 to 20,000, just assume. Now this server can handle those many requests? No, right? Now already regularly, so usually this server can handle 10,000 requests. Now offer time or festival time, many people visiting this website, and they are booking, they are ordering, right? So that time this server cannot unable to handle this many requests. Now there is a right auto scaling concept in AWS also. So based on CPU usage, automatically I want to launch one more server. Automatically I need to launch one more server. I hope everyone know what is auto scaling, what is load balancer, and how it will work. Got it? So now it can handle 10,000 requests. Now a request is coming 15,000. Now CPU is load is high, right? It reaches 70% or 90% CPU usage. Now what it will do? So automatically I want to launch one more instance, same setup, same configuration, same application. Now your incoming request will distribute to two servers. So one request go to this server and one request go to this server. Now this server, so we are splitting request to two servers. So that is nothing but auto scaling. Anyway, see here. So what is the horizontal scaling? If you want to, based on your CPU usage, based on your CPU usage, based on your CPU usage, and you are giving some conditions. So if you reach that condition, automatically I want to launch one more instance. Now your request go to, even if you get 15,000 requests, few requests go to this server and few requests go to this server. So parallelly. Now load will decrease, right? So that is the auto scaling. And also load balancer, distribute your incoming request to multiple servers instead of sending only one server. So that features also available in Kubernetes. So these are the some of the major right features. See here, automated scheduling and self-healing capabilities and automated rollouts and rollback and horizontal scaling and load balancing. So these are the, not only this, there is many advantages available in Kubernetes. So that is the reason we come to here. We come to here. Okay. Now everything available here, how it will work, storage and all. Now this already what are the components and how it will work. So interview mostly they are asking this question, guys. This is very very important. Mostly they are asking this one. See here. So this is the mostly interview they are asking only this question. So can you explain Kubernetes architecture and what are the main components in Kubernetes and how it will work? Now, so now already setup and all everything. Now come to here. So what is pod? So these are the basic Kubernetes objects. So pod, replication controller, replica set, daemon set, deployment object, service object, volume, jobs and all. Now we know what is basics and all, what is namespace and why you go for namespace and all. Now come to here pod. Right, what is pod? Pod always run on the node only. Okay. Now right. So what is pod? Pod is nothing but this is the smallest building block, small instance to run your application. Just remember one line answer, whatever you know. Okay. So interview also most of the people they are asking what is pod, and pod has some properties. So pod is nothing but this is a running process. Now here container is running. So where container is running, guys? Anyone any guess? So I created one pod, right? Now I have three pods. Now every pod, so containers are running. So inside pod only containers are running. Inside pod only containers are running. Got it? So this is the one pod. This is one pod. This is also one pod. Now Docker we are calling containers, right? Here containers also is there. So but container is running inside the pod only. Inside the pod only. Got it? Or if you want to, we can create a single container pod. Now these all are single container pod or multi container pod. Anyone? One by one. These all are single container pod or multi container pod based on here. Here we can see one by one, right? One by one means this is a single container pod only. So multi container pods means we can see count here also 2, 3, 4, 5 like this. How many containers are running in this pod and all. Got it? Hemant, clear? So these all are the single container pod. Right? Sidecar container. Already last class we discussed. Sidecar containers means multi-container pod. Multi-container pod. This is nothing but sidecar. So that pod, in the pod we are going to deploy multiple containers. That is nothing but a multi-container pod. But so as of now we created only single container pod. Only one pod is running. One container is running one pod. Clear? Hey Prem. Hello. Anyone, any doubt as of now? Hello?
Clear, sir.
Okay, one second. So now if you come to here, now this is a pod and all right. Now if you see here, so now so pods, so Kubernetes objects and all, we can create two ways. We can create two ways. So one is we can create like this also. This is the right imperative mode. Single line command we can execute whatever we want. We can execute single line also, or else we can create with the help of manifest. But real time we are following this way. Mostly we are following this way. Where is that? This way. This way, right? So now, so this and all. So you are in first time, right? First time we need to follow some syntax. We need to follow some indentation, and also there is a right. These are the some pattern we are following. So before going to create first time, right? So if you don't know any idea, just if you go to Google and just type uh, create pods. If we click in pod, right, what is pod and all? Pods are the smallest deployable unit of computing that you can create and manage your Kubernetes. Now if you go down, so they given, see here, using the following example pod, which consists of containers running the image nginx image they are using. This is the tag name. This is the tag name. So I created one nginx image, right? I created one nginx image. How I created here? I am using this command simply. See, I created one nginx image. I created see here kubectl kubectl run, and so we can give this is the pod name and hyphen image equal to nginx I given. But here I didn't use any tag and all. So which is the latest? Automatically it will pick. So this is the one way, but real time we are not going to run like this. Real time mostly we are following. So this is the manifest file. If you want to create any Kubernetes objects, we are following manifest file. This is the configuration file, and with the help of this configuration file only we are deploying your application. Okay. Now so single line means we can run like this. Single line means we can run like this. Same thing. If you want to run with the help of configuration file, how to run it? So first we need to create one file. Before that I am going to delete all these things. Kubectl. If you want to delete, but don't run in real time. Delete, delete all hyphen all. I am going to delete all resources in my cluster. Okay, but don't run this command in real time. Okay, so if you run this command, what is happening, guys? As of now, what are the which Kubernetes objects, which service I created, everything I deleted. But real time don't use. Only for if it is in local means we can use this command. Kubectl delete all hyphen all means as of now I created few parts, few service and all. I deleted everything. I deleted everything. That's it. Now see here, CLS kubectl kubectl get pods. Right now we can't see anything. Now see here, I don't have any, no resource found in default namespace. So this is the default namespace. If you are not mentioning anything, all resources are deployed only default namespace. I don't have any pod. Now, so how to create with the help of configuration file. Now see here, so this is right. So this is first time, right? Just copy and paste. Don't do anything. Already, if we have idea, so we need to follow some indentation and all. Just I am copying this one, and we need to create one file. Right, I hope everyone know Linux, how to create file. Vi I am using test hyphen test nginx, or we can use nginx hyphen test dot yml file. This is the extension yml or yaml. We can give yaml or yml. So yml is this is also one simple language. What is this? VI is not available. I am in Windows prompt, right? So VI is not working. We need to use Notepad. Notepad. So this is not Linux. I am using Windows, right? C colon Notepad space and a file name nginx test, whatever name this is, we can give any name hyphen yaml or yml. Extension should be yml. It will open like this. Windows, right? It will open. Already I copied, right? Just paste it. That's it. Already I copied. Just paste it. So now if you go here, file name I given test. Now these are the some right, some tags we need to understand. So this is the first time, right? Try to understand. This is the API version v1 by default. So this is the API version v1 and kind equal to which kind is represents which Kubernetes resource, which object Kubernetes object we need to create. So kind equal to pod. So here we can use pod, here we can use deployment, here we can use replica set, here we can use right, replica controller and service, anything. Kind is nothing but which object you want to create. Now I want to create only pod. So this is the default name. We need to follow same only. Now metadata. Metadata means so name column. This is the metadata. Under metadata subtag name. So name we can give any name here. This is your pod name. This is your pod name. Nginx, for example, Nginx pod I given. Whatever name you want, we can give any name here. So we can give any name here, whichever name you want, we can give that name here. So now I'm using NJNS and so test, NJNS test I given. Now this is spec is nothing but specification, guys. Spec is nothing but specification. Spec also one tag, and this is the containers. This is the containers. Container is the containers, and hyphen name. This is your container name. So hyphen name is nothing but container name, and image. Here I given one command, right? Hyphen. Here I given so this command, right? Same only. Here this is one line command. Hyphen image equal to nginx, right? So in manifest file we need to give like this configuration file image colon which image you want. So nginx, and also here I am using tag also. Here I am using tag also 1.14. Or if you are not giving anything, by default latest will pick. By default latest will pick. So that is your wish. That is your wish. Okay. Now this is the ports. This is the ports. See here container port. Default port number is 80. You know, right? So Tomcat default port number 8080 and Jenkins default port number 8080, and so whatever servers we are using, right? This is the server port number. But Nginx server default port number container port 80. Container port 80. Got it? So these are the sum of tags, and so if already few people know, so we can easily understand. Who are new to Kubernetes, just try to understand. Okay, API version v1 and kind equal to pod and metadata. We can give any name here. That is your wish. This is your pod name and spec containers. Under containers we can use. So this is the name. This is the container name. We can give any name here also. Image. This is very important. This image and all coming from your Docker only. That is the Docker registry. Okay, image, which image you want. Okay, now this is the ports and container port. Ports under container port. So what is the default port number? Nginx server 80. Nginx server 80. That's it. Now control S save, control S save, and so close it and close it. And how to run this file? Now file is ready. Now see here, file is ready. ls, sorry, cls dir. Now see here, this is my file. This is my file. So my file is ready. Now how to execute this file? If you want to execute this file, so everything already we noted. See here. So if you want to, once the file, this is the file. Once that is ready, and so execute. So kubectl apply and -f file name, and this is your file name, yml file name. Now observe here. If you type here, suppose kubectl, just type enter. Here we can see many commands. Here we can see many commands. So now see here, regularly we use command create we can use, and apply also we can use. So create, and somewhere we can see apply also. So these are the commands. Anyway, coming classes we'll see all these things. See here, apply. This is the advanced command. Apply a configuration to resource by file name or standard input. So we can use apply, or we can use so create also. Create a resource from the file from the stdin. If you use create means only first time it will create. If any modification, and if we have update regularly, and that case mostly we are using. I am using mostly apply. Both are same only, but first time means we can use a create. But every time if you want to update, if you want to rerun, that case we can use apply command. Advanced commands, diff apply command. Okay, apply. Now how to run this file? If you want to run this, just assume And right now I don't have any parts, guys. I don't have any parts. kubectl get parts. Right now I don't have any parts and my file is ready. And so dir, this is my file name. This is my file name. How to run this file? So this is the kubectl command line tool. Apply hyphen f. What is f? File name hyphen f. What is the file name? nginx hyphen test.yml. Test.yml. So that's it. Now see here, pod is created. So pod is created. Now check really whether pod is created or not. kubectl, kubectl get pods. kubectl get pods. See here. So what is this? Pod name. What is this? Pod name. See here, one pod is running. What is the status? If something goes wrong, if something goes wrong, suppose we can also track it. If this keep on, if we not creating, if keep on recreating, so that case also we can check it. So that case also we can check it. Now in Docker, if you want to know more about, if you want to know more about, we can check it, right? Inspect command, and here there is a kubectl, kubectl describe and pod name. Now see here. Now we can check it. What is happening? So if you suppose if pod is not created, keep on recreating. There is some issue on pod. So what is happening? Now we can see namespace. So which namespace it is deployed, guys? Default namespace. Now see here. This is the name and this is the namespace. And this is a service account, default service account. Right now I didn't create any service account. What is the node? This is my node name, IP address. And so see here, what is the IP of your pod? See 10.1.2.92. What is the status? It is running status. And see here, what is the container section? What is the container? This is the container ID. And what is the image? This is the image I took. Okay, now what is the port number? 80 and state equal to running. And see everything we can check it here. Everything we can check it here. See here, and what is happening? Now come to volume. Right now we don't know, right? Leave it. And type. See here, scheduled, and 50 seconds ago default scheduler successfully assigned default nginx test to docker. Only one node is available. And see here, pulled means container image nginx colon 1.142. So it present in the already. And so created the container and started the container. Now if you want to know more about interval, also many people asking, for example, if container is not running, there is some issue. It is keep on recreating and trying to create the container, trying to create the pod. So how to check it? How to check it? How many ways we can digging? How many ways we can track? Okay, this is the one command. If you want to know more about what is the command, kubectl describe pod name. Very very important. Interview also many people asked, suppose I want to see what is happening, which error I am getting. So if we have any errors, here we can see errors. I will show you coming classes what type of errors mostly we are getting and how to resolve that errors also will see here also. Now got it? Clear, Hemant? Anyone any doubt here?
I think
So
so.
this is the command. What is the command? kubectl describe pod name. We are using same command wherever in real time also we are using. Suppose my pod is not created. My pod is keep on recreating. There is some issue on my pod. So if I want to know something about my pod, what is happening? Why it is not creating? So what is the issues? I want to track it. So this is the command. So this is the one command. Not only this, there is many commands available. So this is one way. So what is the command? kubectl describe kubectl describe pod and pod name. Got it? Pod and pod name. Pod and pod name. So now we know everything, we can check it. So which namespace we are using and what is the namespace name and what is the that is pod name and whether it is running or not, what is the IP of pod and what is the container and which image. So that everything we can track here, we can check it here, everything whatever we are using, that and all. What is the port number. And so see here, few things will coming classes I will explain. So right now we don't know, right, what is these things, and I'll leave it. Okay, now see here event sections. If we come to event sections, so what is happening, how many steps executed, see here everything we can check it successfully assigned schedule to that particular node. And also we can check which image, whether if it is not available it will pick. And so already is available local machine. Now it is now created the container. Now start the container. Now start the container. Now kubectl get pods. Now see here pod is running. Pod is running. Okay, pod is running. Suppose even if create if delete this pod, some case pod is deleted automatically. Now it won't so it won't so recreating. Now try to understand. Now see here I'm going to delete kubectl 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 delete pod name. Right now I am using only one pod. Now I'm not maintaining any replicas and all. Now see here kubectl delete pod name. Now pod is deleted. Now check it. Kubectl get the pods. Now pod is created or not? Created or not? Not created. Because here I am not using any replicas, right? Here I am not using any replicas. Okay? Here I am not using any replicas. Okay? Here I am not replicas. That is the reason it is not recreated. So not recreated. Got it, guys? Anyone any doubt? Clear? Hello?
Yes, sir.
Okay. Just try to create, first try to set up, and next we try to create the one pod. So first time, right, just Google and copy and paste it, try to create, how to create and all, how to create pod and how to check that pod and check the some information. So as of now we discuss only few commands, right? So how to create pod manually and imperative mode and also with the help of a configuration file. And so how to check the, these are the commands, right? If you want to see the commands, and so if you want to check it, kubectl get pods. And if you want to kubectl describe describe pod and pod name, pod and pod name, pod and pod name. So which pod name? Pod name. Okay, this is the get pods. And if you want to create imperative mode, and kubectl create, and if you want to deploy and anything whatever same command. But anyway mostly I am using a configuration file, right? So like this we can exit. How to run this, how to run? So once your file is ready, kubectl apply -f and file name, -f file name dot yml file. That's it. Okay, so next class I will show you few more things. I hope you got some idea, right? So how to create pod and how to check the pods and how to describe the pod and all. Clear? Anyone any doubt?